Fantastic. All right. So we're going to go ahead and kick it off here, and I'm going to let Darren take it over, talk about the presentation goals.
Right. So we want you to learn about improving just the way you think about QMH programming in LabVIEW. You're not necessarily going to come away from this presentation with like specific things you can do on your block diagram. This is more of like sort of a holistic, how do we design our applications? And Norm and I came up with a couple of things to talk about today to help you think about the design of QMH-based LabVIEW programs in a couple of ways. The first way is to understand, if you've ever talked to Norm for more than 5 minutes about LabVIEW, you have probably heard him complain about the ever-present problem in queued message handler programs and the way that flow can be disrupted in a QMH. So we want to make sure that we cover that topic so that next time you're talking to Norm and 5 minutes passes and he says, hey, did you know? You can say, I already knew, I already know, I saw y'all's presentation, I know the problem. See, that's a good goal right there.
Believe them, that's the thing.
That's true.
Get them to believe them as well, at least I think so.
The other thing that we'd like you to come away from this presentation knowing is Norm's QMH Prime design. So we're gonna do sort of a quick introduction of QMH, then you're gonna get an introduction to Prime. And in his strange brain, Norm has melded those two things together. And even if you come out of this presentation deciding, I don't know what that is, or I know what it is, but I don't want to do it, we at least want you to have an understanding of the QMH Prime design.
Absolutely. And I decided to add another one in just in case you didn't get either of those two presentation goals. Our goal here indeed will be to entertain. We're not comedians, but indeed, hopefully we can make this discussion more lively than some of, just a random presentation you'd hear about, active framework.
Whoa, too soon. All right, so what are we going to be talking about today? Well, we've already covered the goal of the presentation. We want you guys to understand Norm's complaints about QMH flow. We want you to understand his QMH Prime design. But we're also going to go into what exactly the term state means. Now, those of you in the LabVIEW community know I'm not much of a semantic guy. I don't like to go really into the weeds about the definitions of things, but this whole presentation is about state and flow. So we at least need to get our terminology down. Then what we're going to do is we're going to cover Norm's problem statement, like the problem he sees in QMH LabVIEW programming.
All over the world that Darren denies exists. So as you hear these problems.
The argument's supposed to start later, Norm.
Okay.
We're just in the agenda right now, for goodness sakes. All right, so Norm has a solution to those flow problems in QMHs. As you might suspect, I have a counterpoint to Norm's solution. As you might suspect, he has a counterpoint to my solution. And hopefully we will cover all of this and get to the conclusion within an hour.
All right, so before we get started along the way, we wanted to talk a little bit about the nomenclature, because we're going to be tossing words out left and right that you might think are defined differently or might take them different ways. And as Darren's not necessarily a semantics person, I believe words actually matter. Let's go ahead and at least clear the air. So a couple things that are clear as chocolate milk. I don't know if Scott Mengele happens to be watching, as a mentor of mine from TI back in the day. Love that clear as chocolate milk. But as you hear me talk about this concept of state, I think of state of a program as similar to the mode of a program. We're going to talk about what mode is as well, but I kind of use those interchangeably along the way. When I talk about state, and I think Darren too, I say it is the state of a program. I'm not talking about the state data. Now, there are probably purists in the world, people who are trying to talk in. Yes, there's the arguments to be made, but when I say state, I'm not necessarily speaking state data. I'll try to use those separately along the way. Actions, messages, requests, I will use those pretty interchangeably as well. And so the DQMH, it's requests, right? That's the thing that goes into a DQMH module. There's messages. I have to say messages because it's a queued message handler along the way. I like to think of them as discrete actions because that's kind of what it normally is most of the time. Actions and messages are not equal to state. So for anybody who's done a queued message handler, and you know who you are, that has referred to that case structure and every frame of the case structure as a state, you're wrong in a variety of different creative ways. But so yes, actions and messages are not equivalent to state, and that's a big one. And then do, which is active framework speak, that's kind of like the do. It's the action or the message-ish, right? So that's kind of that, how that flows along that way. And then lastly, the brains of a program, this is definitely a new term, unless you've heard me talk about this before, is equivalent to this state machine, or the brain or the brains of the program. So let's talk about, hopefully that's all clear. Any questions? We've got somebody moderating for us. Any questions out there? Nothing. All right. If you've got questions, we've conscripted another TSC over here to help us with some of the questions. So feel free to post some along the way. He'll filter for us. So what is a QMH-based library program? Hopefully, for those of you, well, some of you might just be waking up right now.
That's true.
We're just logging in, but in general, there's been a variety of presentations that have touched on this concept. But what is a queued message handler type program? Well, there's the NI example program QMH. There's the Delacorte QMH, which of course Darren's near and dear to. Even actor framework. At the core of actor framework, every little actor is still a queued message handler. So if you think, I don't know what actor framework does, it's a bunch of queued message handlers. So don't be too tossed aside from that one. TLB Prime, TLB 2.0, TLB Full Tilt. All of these acronyms that you've probably never heard before, unless your name is Alex C in South Korea. Hi, Alex. Sorry, it's a small community that I work with. But in general, or even the JKI state machine, each one of these things is very specifically a queued message handler along the way. But at the heart of it is what you see right there. It's a DQ element that is usually either a string or enumeration, let religious debates ensue. And then it goes into a case structure that declares what should happen when you DQ a thing from that thing. All right, that's queued messaging. So
I just want to take a quick aside here and talk about the templates that we choose to develop with in LabVIEW. As much as it may seem within this first couple minutes, this really is not a presentation about my framework is better than your framework. All right, that's not our goal here. Get off the screen. Lots of people have been successful with lots of different frameworks. That is a fact, all right? There are a lot of engineers out there who have made a lot of money writing LabVIEW applications with a lot of different frameworks, and I'm not here to take away any of that. You didn't have to get off the screen, Norm. You can come back. Like, for example, DQMH. That is a framework that comes naturally to Fabiola, obviously, because she wrote it, and Matthias and Olivier and me. We all, that's just the framework that comes naturally to us, and that's okay. Actor framework. Comes naturally to Stephen and Alan and Derek and Casey and all sorts of other AF developers, and that's okay. Both frameworks, very good, very successful. TLB Prime comes naturally to Norm.
There's more.
And
there are people.
And that's okay, all right? So that my point stands here. We definitely all need to sort of get out of this whole my framework's better than yours. So let's hear about TLB Prime.
All right, so TLB, which is a top level baseline. It was, what is this thing? So at the heart of it, TLB, before even the Prime concept, was just a queued message handler template. Because back in the day, all that we had in LabVIEW was producer-consumer. Dear Lord, never call a queued message handler a producer-consumer. Please don't. And sorry, passion ensues here, right? Coffee and beer, right? So queued message, but it's the top level baseline. The idea is create a template for a queued message handler that will be basically, after you open it up, if you build it into an executable as it is, it looks like a nice program. It elegantly shuts down. It doesn't need a big stop button. It just has features that are kind of cooked into it so that you can take it from, I want to make a very simple thing and bump it up into a program really quick. So just stuff that I learned over the years, built it into a template. And then there's this idea of the Prime concept, or the Prime directive, if you will, for the Star Trek fans in the world. But the basic idea is what I did is I took the queued message handler and I left it alone, and then I bolted a state machine as the brain of the program in adjunct to the very familiar queued message handler structure itself. And that now what ended up happening is it separated this idea of flow control and the do's. So there's the actions or the messages or the doing of the program, and now figuring out what to do next or what should happen in order is now relegated over to this brain or the state machine of the program itself. And we'll see an example of this. I don't think I do the demo at this point.
Right. We'll do one later.
All right. So in general, this template, this idea was to address multiple common issues that you would run into, or so many people run into when developing queued message handler based programs along the way. Yes, I'll leave it at that. And of course, Darren had to get his 2 cents into this slide, and his definition of what it is that it is a sophisticated stateful trigger response mechanism with a shitload of white space. So you'll see what that necessarily means in a moment along the way, and you can judge for yourself in terms of what you think matters.
All right, so thanks for the intro to TLB Prime, Norm. I'm going to give a quick intro to DQMH. DQMH is a LiveView application framework. It's an event-based framework that came out several years ago, probably around 2014, 2015, around that time frame. And this is a framework that is, I lost my clicker.
Sorry, I'll get you.
Norm's clicking on stuff and messing me up.
I'm sorry, it's just...
He's trying to distract you guys. He's trying to have y'all marinate in the TLB Prime for just a little bit more during my slide. Anyway, so all right, so DQMH. It is not a framework that comes with LiveView. So the NIQMH, the active framework, those come with LiveView. DQMH is a download from the NI Tools network. And once again, my clicker.
Yep. Oh.
Norm's my clicker.
Anything I can do to throw you off.
Norm's my clicker guy. He's the one I talk to when my clicker breaks. All right, so the DQMH, it is maintained by an organization called the DQMH Consortium, and there's you are right there. So what's the deal with DQMH? It is a framework that if you ask the woman who wrote it, Fabiola de la Cueva, she's going to tell you that the framework actually isn't the best part of DQMH. She's going to tell you that the productivity tools are the best part of DQMH. So the tools that are built into the framework to make you a more efficient LiveView programmer, the tools that will automatically create the requests and broadcasts for you, the tools that will keep your API tester VI updated, all the tools that will validate that your module follows best practices up to the latest version of DQMH, all of those tools that are built into the framework, those are sort of the shining star of DQMH. Now, the thing about DQMH is it uses a terminology that might be different from other frameworks. If you have code that wants a DQMH module to do something, you would say that it sends a request to that module. If your module wants to tell the world some information, then you would say that that module broadcasts that information. And those requests and broadcasts are implemented in DQMH with user events. So if you look at different frameworks, you'll see that Active Framework, if you dig down, it uses a queue, for example, to facilitate that communication between modules. DQMH uses user events. But again, most of that is abstracted away from you as the programmer because of the productivity tools that are built in. But why is it called DQMH? If it uses events, the reason is because the external world communicates to a DQMH module with user events, but the module communicates to itself with a queued message handler that looks just like, or very similar to the NI queued message handler. So that's where the name DQMH comes from. Oh, and since Norm had to do my quote, I will have to do his quote, which is that DQMH is a ridiculously tool-rich QMH that fails to solve the big issue and thinks you'll fit code into 550 by 380 pixels.
I mean, who codes? It's that small. You get like three, like not even. It's.
I've been successful with having that amount of real estate on my block diagram.
You special snowflake. All right, where are we at next? All right.
All right, so we've got this term, state, yep. Right? We've said that 500 times in this presentation. And I wanted to find state with an analogy. And that analogy is that the iPhone is not a phone. It is a personal internet connectivity device that you probably use every once in a while as a phone, all right? So just like the iPhone is not a phone, the simple state machine is not a state machine. That is the template that ships with LiveView. It's called the simple state machine. My colleague at NI, Christian Lowe, some of you guys probably know him. He hates that term for this framework because it's really not a state machine. If you dig in and you look at it really closely, what you see is that this thing isn't really maintaining any state. That enum is not defining a state. It's defining what to do next. In other words, it's giving you a message of what to do next. So this thing, I would call it the single message handler. I would not call it the simple state machine. Similarly, like Norm said earlier, you'll hear LiveView programmers refer to the different message frames of a QMH as states. That is also wrong. Those are messages. We are telling the code to do something, and then we're doing something, going back to your do example, doing something in that case. So again, also not a state machine. Norm, can you tell us, what is a state machine?
Well, before we even get to that one, I wanted to kind of clarify a little bit more about how, if you're programming in this method, if you think that your your case structure frames are states of your program, or you're making your simple state machine, your states have doo-doo all over it. Because as you can see, hopefully here in this diagram, hopefully it's crystal clear. If somebody can't see that or it's fuzzy for y'all, please send a message. You gotta watch for it. But in general, what it is that if the common way of thinking about state machines in LabVIEW, the erroneous way, is that you have a bunch of do's and you have do-dos all over your program. Go to this and do this, and then when this happens, do this, and when this happens, do this. And that just doesn't necessarily work. It doesn't match up with reality in terms of what your program needs. And in fact, it is usually the core of a lot of bugs. So I'm going to read this one very specifically. Y'all see it on your screen, but this is really important. A better definition of state, in a way that can kind of break your mind out of the common problems that QMH has caused, once we get into QMH right here, is think about state as the discrete mode of a given module which classifies specific behavior to stimulus and to data. So a discrete mode of a program that classifies what it should do when it gets stimulus from the outside and it has current stateful awareness on the input. And so a way of thinking about this, or a way that that you're talking about the states of a program, is it's all the ings. I've heard Mark Bala reference this. He's you'll see some of his examples later, but it's all the ings of a program. I am idling. Oh, we'll see some examples of what those ings are later, but it's the state of being of the program, or the modes of the program. If you've ever had a program where all of a sudden the front panel will change, either you will get forced to a different tab, or you'll enable and disable very specific controls because, I wasn't connected to hardware before, but now I'm connected to hardware. Well, if you're connected to hardware, then you might want to disable certain things, or you might want to enable certain things if you're connected. Those would be a way of indicating to you, based on the programs that you've already got, those are the modes or the states of the program. Another definition is the functionally contained behaviors and responses. And so if you think your program should behave differently to a button push or some internal register value, that's pretty much a different, it's like, hey, same stimulus, I'm going to behave differently. That's an indication of different states of your program. So for example, you would say that I am idling in this case, or I am connected. There's no connected-ing, of course that doesn't make sense, but you can get the idea. It's a state of being, or monitoring, or logging, or shutting down, handling an error. These are the state of being. There's a lot of actions or a lot of do's that can happen in these states, but to me, it represents, and this is where it's a little bit different, it's so natural to me to think about a program and talk about, or a module, not even a program, right? A module within a program, right? And Darren's going to talk about decomposing programs into smaller modules. But even those small modules, I am frozen. All right, so we are live. If somebody sees that we're frozen, there's going to be about a 30-second delay. We'll put something in the chat to see if anybody else says that we're frozen. It could just be you. Hold on, wait. So if anybody is in the stage room, can you please let us know if we're frozen? Okay, well, I got a thumbs up. All right, we're going to keep going. Thank you. All right. So sorry about the delay on that one, but indeed, that's just that natural flow. And so the way that I, Norm, and other people who are sane would like to describe.
Nobody would ever describe you as sane.
That's true. It's slightly abnormal. But indeed, it's easier for me to describe my program as I'm idling, I am connected. This is just really a drawing. But guess what? There's syntax for the flow of your program that actually matches if you have things going from mode to mode to mode. And it's not that you can't diagram, you can't use a flow chart. You could use a flow chart to print how your program is going to respond. But who here has printed a flow chart, taking out time on a line plotter at work or FedEx just to print out how your program was supposed to flow? And this speaks a lot easier. It speaks more concisely, and it actually fits really, really well within common programs in this one. All right, so that was probably enough on that one. I appreciate it. And if it hasn't been clear at this point, the idea with the traditional QMH, and this is the big problem statement, all but the most simplistic, Darren's going to jump on that one in a minute, but all but the most simplistic of QMH modules will suffer bugs, have difficulty debugging, or implement poor fixes or workarounds due to no stateful and explicit flow control. Everyone. So let's actually talk about how you know if your queued message handler stinks along the way. So if at any point in time you happy dancing on a button, like, hey, your program hangs for some reason, like we had a hang 5 seconds ago, somebody in the room tells us, hey, so what was he doing? Hitting on the button, mashy, 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 right? Well, how many of you have programs that can't handle that kind of random delay that happens at random places? You could have, here's your sign, your flow stinks. Another one is understanding the program operation is not obvious from the code. And I would contest this even with Darren's example you're about to see, that there's no one place that you can actually observe or witness how the program should flow ahead of time. You can see maybe how it responds to a discrete behavior, but not necessarily how the whole thing should flow. Another one is the code that is actually controlling the flow is mushed together with the code that is doing the do work along the way. And that's pretty huge, because for me, that's a functional containment is absolutely important. And so when you have that, hey, what should I do next? Well, let me go ahead and preview my queue along the way. Ah, there you go. Or worse than preview queue is flush queue. If you've ever done that one, Darren, at least we were
100% agreement
on that one.
Boom.
Never flush the queue, please. And if you do, your flow stinks. Or possibly another way to put it is, if you never actually spent any time thinking about the actual flow of your program and how that should be controlled and the problems that could happen before they do, your flow probably stinks along the way. So this is probably a pretty good example, and I'm just going to highlight it here, and I wish we had more responsiveness. Let me go ahead and do one of these numbers. All right, so in this case that we've got right here, this is a queued message handler for the ATM example. So this is a coworker of ours. He's getting up, he's trying to learn how to get a CLD, and so he's doing these sample programs. And so he just does a queued message handler built off of the template that people and I made.
Yep.
And he starts to just implement it in a way that lets him, that just kind of matches with what his brain is. And so if I'm delaying a little bit. Hopefully somebody, Lane, you're going to be my guy. I want at least one person to say what bug they think might be in this code. So we're going to go ahead and we'll delay a little bit here. But indeed, this is the ATM. This is to kind of set the stage for this presentation. We'll wait for some responses. Darren, actually, I pinged Darren. I'm like, hey, Darren, show me what your implementation of this in the queued message channel, DQMH, looks like. And I'll do the same with TLB Prime. And we'll just kind of compare and contrast notes and hopefully create a presentation that, gets us on the stage at GLA Summit and things like that. So win for that one. But do we got any questions? Did you get anybody? Nobody spotted bugs. All right, y'all lose. In general, let me just go ahead and highlight out some of the things that really jump out, if I can. Oh, there we go. Give them time. It's a labby diagram. You just absorb the diagram. You don't read diagrams. You just.
Here's some from Derek. Something gets inserted between those queued messages.
There you go. That's a great one. So if something just happens to get inserted at that instance because there's somebody else out in the world over here that has access to that same queue, and they decide to drop something in between. That's a beautiful and appropriate one.
Queuing messages to oneself. It's a general race condition problem.
General race, absolutely. Thank you, Dr. Powell. And indeed, the other one that ends up happening, and this is a huge, huge one. This is a message or an action or a do, depending on what you want, called check account. Can you imagine for a second, and this Darren's going to tell you that, these, when you say what ifs don't happen, but what if? What if somebody else wanted to call the check account action? What's going to happen? Well, let's think about that. I'm going to check the account, but guess what happens? If there's sufficient funds in the account, well, I'm updating, I'm withdrawing. I just wanted to check my status of my account. Who the f is withdrawing money from my account? That's a bug, right? And that's a really great example of this lack of functional containment. There we go. Lack of functional containment because we have, hey, this is kind of making some logic, but then it's actually saying what to do after the fact. That's, like I said, in a simple diagram from a wonderful human being, a humble guy who actually is pretty smart and thoughtful of it, just still created this bug inherently because that was the way that it made sense to control the flow of his program. All right, enough soapbox.
Hey, go back. I want to say something quickly about this diagram. And so this was written with the NIQMH, as Norm pointed out. You can tell by looking at those sub-VIs, those are the ones from the NIQMH. And I want to point out that just because our colleague used NIQMH, that doesn't mean that he was guaranteed to have these bugs in his LabVIEW code. If you know what to look out for, if you are familiar with some of those patterns and problems that Norm has talked about so far, using this framework doesn't, destine you to a life of race conditions.
Just walks you right into it.
However, if you are not careful, you can encounter those issues. So I just want to point out this isn't an inherent flaw with the framework. But it is something that can sometimes be a little easier to happen than other times with the framework. Yep. That's all I wanted to say.
Cool, appreciate that, and very true. And so at the core of it, the performing a specific action, and I already said it, and making choices of what to do next are categorically different things. Absolutely 100%. They are different things. They are different in kind and type and everything else along that way. So for those of you who follow Solid, which is, if Dimitri's in the audience, hi, Dimitri. Dimitri, what's his last name? It's a very...
Sagatalian.
There you go, one of those. Amazing guy, another guy in the community. You'll notice him by usually a very dense white beard, long hair, and glasses. Indeed, but he's a prophet of Bob, Uncle Bob, is Bob, what's his...
Gang of Four.
No, Bob's not a Gang of Four guy.
Oh, he's not a Gang of Four?
No, he's...
Oh, you're right. Sorry.
Anyways. Coding principles, I'm sure we'll get it in the comments soon enough. Uncle Bob, but you'll talk about solid code programming principles, which S ends up being single responsibility principles. S'mores is one that I'm a bit of a prophet of, and for scalable, modular, reusable, extensible, and simple, and it breaks functional containment, which is that modularity aspect of it. So basically, in general, if I just start with a queued message handler without a brain, my brain breaks because there's no, I have to have that functional containment along the way.
Martin.
Thank you.
Martin, thank you. All right, so program flow varies based on the mode of the program. So let's give another example of this one. So the state nomenclature is a natural self-declarative method of defining modal flows. Up here. Okay, we're going to go with this one. We're going to do side by side. All right, so perfect. Oh, nope, we wanted to do so close. There we go. All right. So trying to get fancy here, folks. Thank you. This isn't necessarily my day job. Okay, so let's talk about the state nomenclature in general. Right. So why can we even? Is this some weird thing that never even applies to us in our daily life? And I would say no, it absolutely applies. So let's take an example from our own life. You behave differently to requests based on your current state and state data, right? Things that are happening. So I'm a father of twins, lovely girls, and I would get a request, change my poopy pants. They're about 3 years old. They can say these things now. And so, of course, my state, if I indeed am daddying at that point in time, well, what is my response to that? What are my actions I'm going to do out of that with the doo-doo? I will break out the wipes and the nose clips, and I will continue to take care of my lovely and beautiful daughters. This is Maya, you see right there. However, different states cause different responses. And I bet you're all wondering, I'm going to pause here for a second. What is he possibly going to bring up? All right, so if I was bachelor partying and a good friend of mine says, change my poopy pants, well, you better bet my response is going to be a lot differently. I will push him out of the car near the closest gas station and maybe come back for him along the way. So indeed, that is how that goes. All right, so now that begs this question, that's actually probably, never begs the question, it's not right. But in any case, how much do you care about state and flow? For me, in TLB Prime, and usually it says that prime directive really is the, I elevate it, it elevates it to the top. The absolute, like when I work on my program, I think about that first. And we'll talk about that when I see the ATM program that we'll see in a second.
Okay, so when I write a DQMH application, state and flow is not a first-class citizen in my mind. I'm being completely honest here. The thing that I'm thinking about is how my modules, or my actors, if you want to use more general terminology, are interacting with another. So the state, yes, it could come up. It's an optional component of the design as far as my view of DQMH is concerned. But the majority of my time when I'm designing my DQMH-based application is the splitting up of responsibilities between modules and the APIs through which those modules communicate. So like it or not, if you're using AF or DQMH or Messenger or NIQMH or JKI State Machine or anything, the framework you have chosen is undoubtedly going to affect how you think about and how you design your application. That's just the way it is. You can't come in with a single mindset and apply it to any possible LabVIEW framework. That's just not going to work.
Yep. And similar and kind of contrapositively, actually, and then the framework that you will naturally gravitate towards will potentially be also one that fits your brain that much easier. Now, it's good to get experience in a variety of different ways of modes of computation, if you will, on the G diagram. But indeed, so they're intimately linked, and I don't disagree with that one. All right, so I think what are we supposed to be 15? We're still supposed to be 15 minutes in. We're running a little bit late.
Yeah.
All right. So I will speed it up, and I'm going to show the solution that I've got right now to the ATM in short order. And Lane, keep an eye on that chat and see if there's anything else that we need for the questions here. And let's go to demo. All right. So let's go ahead and, but I guess the thing that I wanted to showcase is I'm going to show the ATM solution, but I think possibly more importantly,
Please leave me enough time for my demo.
I will leave you enough time for your demo.
Appreciate it.
Is to talk about an even more simplified version that's not built off the TLB template, but it has the prime directive really as part of it along the way. And so this is going to be a very simple program that I used to illustrate the problems with the queued message handler. If anybody wants to see this, you can look up like the CLA Summit from 2017. But basically, if you hit the start button and you hit, basically the start button a couple of times or did the happy dance, it starts, there's problems that end up happening. And this is just basically a standard queued message handler in the system. We're not going to go through that. You can watch it later. But what I wanted to show is like, well, then what does TLB Prime look like for this very simple system? And at the core of it, it still just has basically our actions being handled down here, and it still has our event structure happening up top. But down here on the side, there's actually the brain of the program, if you will, kind of bolted on, where, hey, it says, what state am I in? What input have I had to the system? And then what state do I go to next? And what actions do I do along the way? And so that's the thrust of like this whole section over here. If I had to say, what's TLB? Do you see TLB on this diagram? No, you do not. But what's the prime part of it? It is this section that's over to the side. And the reason that it's so important is because when you look at TLB Prime, not only does it have more than like 640 by 480, actually yours isn't even 640 by 480, it's like 380. Anyways, microscopic amounts of block diagram. I don't want you to get lost in the weeds. But also another thing that I'd like to highlight is on this diagram, I wish Antidoc would automatically make this for me, but I have basically a state machine that I can use to talk to Darren or anybody else like yourselves to say, hey, this is how my program should flow. And you have an expectation of that. So when you want to change the program and there's a what if that actually happens, you can gracefully and elegantly add that without wrecking the flow of your program. So I'd start up and it goes to idle, and then it gets some stimulus and it causes it to go to processing, and it does some processing for a while, and then it goes back to idle, and that something causes it to eventually go to shutdown. And we could walk through this, but we're not about to do that aspect of it. All right, so there's that, which was one thing. And then my implementation. So for ATM Prime, for those of you who have taken your CLD or not seen the sample test, basically you run the program and it will go ahead and load up a bunch of soft buttons along the way and basically allow you to do inserting of, simulating the inserting of a card and things of that nature. So 1, 2, 3, 4, there's my bank account, press to insert card, there's the enter validating. And so hopefully that kind of illustrating not only working as a functional demo, but you've seen some extra information even get displayed down here, possibly a little bit too fast for the moment, but I was even displaying the state of the program down there kind of as a nicety for me as the developer along the way. So let me go ahead and go to the block diagram here. And what you'll see, of course, is the shit ton of white space that we have that's along the way, but this is an extremely simplistic program. that, definitely, depending on how many drivers you're calling and what other things that are happening, this tends to get filled up. But indeed, so here's all my individual actions of the program, where you can see that I have a very load soft button menu as a thing, validating the account, removing funds, very specific actions associated with the natural flow of the program. But if I were to flip through these things, there's one big thing that you'll notice that's right here. This queue never makes its way, let's go ahead and do that a little bit smaller there. That queue never makes its way inside that case structure. And that's because an action should never in-queue another action to itself. You ever seen a person, well, yeah, seizures are nothing to laugh about. In any case, when the body starts to give bad feedback onto itself, bad things happen along the way. And that's kind of what ends up happening when you allow the muscles of the system to control the system instead of the brains. And so what's over here to the right-hand side, basically, is the brains of the program. Now, currently, let's go to maybe a worthwhile state, and I'm going to kind of try to navigate you here a little bit. What ends up happening is I look at what is the current state of the system, and then based off of the state of the system that is identified right there, then we look at this secondary queue. And this is the big thing. This is how the brain gets implemented appropriately, is you break and you provide two separate input or one queue to the system to allow for those queued actions to happen, because that's kind of a natural syntax in LabVIEW nowadays. But you have a secondary queue or secondary pipe that allows the brain to be informed of what somebody on the outside world, even outside of the current program, wants you to do. That's not that different from a request, really, but we'll get into whatever that is. And so if I were to walk through this program, and I'm not going to do nearly as much as I would like to do, but let me go ahead and go to, let's see.
Is there any questions so far, Lane?
Not yet.
Okay.
It's that clear, apparently. So if I was at the menu home state, so that's the state of the program. I'm not menuing, I'm just menu home. It's the state of being. It's going to have things enabled and disabled, and it's going to respond differently to different things. And so if somebody asks for fast cash while in the menu home state, I'm going to do some very specific things. I'm going to look at some private information. I'm going to go ahead and say, hey, I actually want to remove some actual funds. I'm going to update maybe the status of the program. And then I'm going to, basically let this run till its completion, and then I'll go back to the rest. Now, like I said, there's a whole mess more I can kind of talk through in terms of describing the flow of the program here. But for the sake of time and everything else, this is what that implementation indeed looks like. So this is where I make the wise choices based off of, once again, state and information in the program and requests. So three separate things. What state am I in? What requests have come in? And what's the state data of the program itself? And with those three things, I should be able to make extremely intelligent and robust choices as to what to do next in the world. All right, so for the sake of time and Darren's thing, I will go ahead and bequeath the remainder of the time over to Darren. And there's that. Oh, I stepped on top of my slides. Indeed, this what we're seeing here is wrong window. There we go. Indeed, is I made two separate modules to go ahead and implement my ATM. I made one which was not a completely monolithic program. It was just pretty much it's doing lots of things. It's taking care of hey, is the card inserted? Am I validating the account? It kind of transitions right through if that worked. And then, hey, I'm sitting at home, and then I can maybe do a bunch of different stuff. But then these are the states of the program. But then these are the triggers of the program. And you can kind of make these akin to the requests in the DQMH world and whatever else that you might have. But indeed, these are the things that every state has the authority to choose what to do or what not to do with in different ways. Similarly, I made an account manager module, which is another TLB Prime instance that basically has a very simple state machine, but it's robust and it's easy to understand how it's supposed to flow. I'm in idle, and then when I get a command that says connect account DB, guess what I do? I move over and I go to the, I do all the necessary things along the way, and then once that's successful, I'm in the database connected state. And if somebody says, hey, go ahead and withdraw, but I'm not in the account locked state, I should probably ignore withdrawing money because I don't have a locked account on that. So things of that nature. But this is syntax that gracefully does allow for that.
Whew. All right, so thanks for giving me a few minutes of remaining time, Norm. Yeah, there's a lot more, you guys. All right, so so Norm implemented TLB Prime with, or implemented the ATM with TLB Prime. He asked me to implement the ATM with a DQMH. Now, when I did so, you might have realized that when Norm was doing his demo just then, he was focusing a lot on that enum, that state enum in his TLB Prime. My implementation of the ATM DQMH has exactly one state variable in the entire code base. So quite a bit of a different approach to, I did not make obscene gestures when I was sitting in the background.
You're lost, man.
I lost an opportunity. All right. So before I talk about my implementation, though, even after Norm just gave me a big thumbs down, I feel obliged to talk about Chewbacca for a second. So this picture was taken at my son Sage's 5th birthday party. He's 14 years old now, so quite a while back. He's almost 15. And as you can see in the picture, this was a Star Wars themed birthday party. The piñata head was Darth Vader. The stick to hit the piñata was a lightsaber. And the Chewbacca holding the piñata was Norm. So Norm, I don't know how much he spent on that Chewbacca costume. I guarantee it was too much. He's probably still paying it off to this day. But all this to show that Norm and I are very good friends. We've been good friends for a long, long time. So it's not personal, the fact that I'm about to try to tear down everything that he said so far in the presentation. All right, so what if, right? This is one of my favorite memes of all time because it comes up so often when I see other people's LiveView code and when people see my LiveView code. It's kind of a statement on over-engineering, right? And that term itself is pejorative. I don't like to say it too much. But the what-ifs that Norm brings up a lot when talking about state management and queued message handlers, in my many years of experience writing pretty complex LiveView applications, they don't come up that often. So there is a level of engineering that needs to take place, but there is a level of engineering that, in my opinion, may be going beyond what is necessary. So my solution for the ATM, right? So whereas Norm sees the ATM and the first thing he wants to do is figure out how exactly the program is going to respond to triggers, right? I'm in a certain state. How do I respond to this trigger? That is the first thing in his mind when he looks at the problem that needs to be solved. That's not the first thing that comes to my mind. The first thing that comes to my mind is how am I going to divide up the responsibilities of this application? So the first thing I thought of was the modules that I'm going to need, the DQMH modules that I'm going to need. And I thought of, I'm going to need a module for managing the timer, a module for managing, because if you don't do something on the ATM within a certain period of time, it logs you out. So I need something to keep track of the time. Another module was managing the accounts, like everybody's balances, and taking care of that as you increase amounts or decrease amounts. And then the main application, the UI that you see when you interact with it. Well, it turns out that across those 3 modules, I needed exactly one piece of state data, and that was an enum telling me what I'm waiting for the user to do. That is literally the only thought I gave to state. Now, coming back to something that Norm said very early on in this presentation, when he was complaining about the problems you can have with a QMH, his exact words were, all but the simplest QMH ... And what I'm here to say is my DQMH modules are extremely simple. And that is one of the reasons why some of these state management issues don't affect me that often. I'm not going to say it never happens. I have definitely had to write some brains in some of my DQMH modules over the years, but not that much. Now, real quick, you guys have already seen some cool content at the summit on Antidoc. That is the tool that I used to generate the image that you see right here of the relationship between my modules. A literal click of the button is all it took me after my application, or after my modules were designed, really, and the requests between them were defined. A click of a button is all I needed to generate that diagram. So just another plug for Antidoc. It's a great tool for documenting DQMH applications and other applications as well. So before we get to Norm's counterpoint, I have a few minutes at least I think I can spend to show off my application. So if I go into LabVIEW and open up my project, it is this one. All right, so I've got 3 modules, the ATM, the timer, and the account manager, like I talked about before. And one of the awesome things about DQMH is the fact that it creates a tester for you, and it keeps that tester updated as you update your modules. So with very little work, I have this tester VI that I can use to basically make sure that the timing part of my application works without having to run the actual application itself. So one of the really cool things is, once I'm sure I've got my timer the way I need it, I run my tester on it, it's good to go. I basically, at this point, now just need to call the public API out of the timer in my main application. Never have to touch it again. One of the really cool free things I get in DQMH. So if I just go real quick and look in my main application. And real quick, one thing I do want to mention, because Norman's going to touch on it later. So talking about the, wrong button. Talking about the managing of state in an application. Now, this timer module is very simple. If you've never seen a DQMH block diagram before, well, first, you're missing out. But secondly, what you see on the screen right here is all boilerplate code. So this everything you see right here, these two loops, all the stuff around them, that is part of the framework. And in this module, I modified exactly 0 of this boilerplate code. Instead, what I added was something called a helper loop. So in DQMH, you have the ability to basically throw on as many extra loops as you want in your module that can handle things like periodic tasks that have to take place. Like in the case of this, I need a timer that I'm managing, or a state machine. If you really do need to put in those brains into your module, it can probably be implemented as a helper loop. I'm running low on time here, so just one other thing I want to point out is in the main application. So here is my main VI. So this is my main DQMH module. As you can see, those two loops, that familiar pattern. If you're familiar with actor framework programming and like setting up the actor tree, right here is kind of the analog in DQMH where a module will start and synchronize events to what we might call child modules. That's not what we call them, but conceptually that's kind of what they are. This is a way to make sure that any dependent modules are running and synchronized before you ever try to do anything with them. And then finally, one other thing is Norm is always complaining about this space right here. So I'm pretty sure all I need to do to get him to start using DQMH is just this. So you guys, I'm pretty sure we now have an official convert to DQMH because now there's plenty of white space there for Norm. You're welcome. Uh-oh, that started over.
No, it didn't. No, that was the back of it. Keep going back. There we go. All right, we're good. Now that we're done with that, let's get on to this other aspect within the extremely short period of time. We're 10 minutes over. That's okay. 10 minutes is doable. But actually, before I even go into this, because we've gone back and forth, and I know that a lot of you are probably in the audience kind of soaking this all in. Let me see if I can just do that. I can't just do this. I'm just going to pause for a second. I'm going to actually make a bigger point here. Because you're probably not going to walk away with a ton of like, oh, I need to do exactly that thing that I'm going to remember right now. And probably maybe even the more important audible that I'm about to call right now is talking about that thought process and learning how to break down the problems into those small nuggets. Now, when I break down my problems into small nuggets, I'm doing it with regards to indeed modules, but then also state. But I don't have this, all of this doesn't necessarily have tooling around it right now. And I really want to get, Fabiola, if you're on the line, and Darren and the DQMH consortium, and everybody else that has influence over what DQMH is, to figure out how to make that reality as part of that, because there's so many tools. The whole industry that I've been witnessing at this point in time, as much as I wasn't able to get people to start thinking in terms of Prime, and I still want it, and I will always think in that way. There's just so many tools that either exist around Actor Framework right now or DQMH. And there are other frameworks that end up existing out there. But the reality is I envy Darren in his ability to actually tear apart these problems into modules that he said, I never run into those problems that everybody else walks into. Right, and I showed an example, right, that ATM example that our coworker built. It's like very clearly, that's a problem that I see all the time, but Darren says he never sees it because he's only mostly looking at his code, code that he's created along the way. But I would say that the worthwhile discussion to pause and have is this idea of what makes, how do you separate how small to make a module and how to slice those barriers between the two? Because that's the thing that I still gravitate, I think as a lot of people do, towards the I have a one large program. And that's easy for me. And I think for a lot of you who are out there that I have one large QMH program. And I say that, you're destined to a variety of degrees of failure due to flow control. But Darren says like, hey, if you break the program apart smaller, that's not the big thing. So can you give people more input that's probably gonna be more valuable and actionable than what I'm gonna do right now?
A lot of it is intuition, to be honest with you. And actually, right now, my intuition is telling me we have 7 minutes left, so we should probably keep going.
That's I'm gonna skip over a part of it.
Okay.
Really, people are gonna walk away more valuable from that one.
Yeah. Just real quick, when you've programmed in LabVIEW for a long time, which a lot of us have, you start to recognize patterns. For example, when I saw the CLD, the prompt for the ATM, and I saw the sentence that said, if the user hasn't done anything in 10 seconds, log them out. Like, my head, after 20 years of LabVIEW programming, was immediately like, all right, I'm going to need a timer module. And then I kept reading the prompts, and it was like, there's going to be a file that's going to keep track of the balances of all the people. And so my head's immediately like, all right, I'm going to need a manager for that file. And the ATM has a UI. It's like, oh, well, there's obviously going to be a module for the UI that's displayed. So reading the prompts and having 2 decades of LabVIEW programming experience helps to be able to make those decisions. So back to your previous point, the more conversations that we can have as a community across people of varying experience levels, I think can help people sort of develop some of that intuition as they continue developing more LabVIEW
applications. So what should people
applications.
do who are just getting started on this? Like I said, for me, I don't have a TLB Prime. I don't have a Prime consortium. If anybody wants to start a Prime consortium, let me know. I'll gladly do it. But there's a whole consortium for DQMH. If people are trying to, I want to do this and I want to be smart like Darren. I want to make robust programs that, until the Prime directive gets integrated into DQMH, what are the guides towards people like, or is there like a forum where like, I have a problem, help me break it down?
We could probably have a whole presentation on that topic, but the forums is pretty much a huge starting point. Actor Framework and DQMH both have dedicated forums where experts frequently contribute there, and people can ask framework level questions and get guidance to move in the right direction. So the more discussions, either in person or online, that take place on these particular topics, I think people are going to have a easier time getting up to speed on how to make those decisions in their frameworks.
How to make it robust by virtue of getting it down to that nitty gritty core thing that maybe doesn't need state associated with it to make it happen.
Lots of experience and conversations with those that have it.
Cool. All right. Well, thank you. I appreciate it. I mean, he's rolling with it. He's usually like, I'm going to do this. I'm all over the map. But what I'm going to do here is at least highlight this other idea of what the solution would be along the way. And this is this idea of the brain that could be at the heart of DQMH has been implemented by 2 other people. There's Prime Test, Dan Press and Mark Balla have gone through and figured out how to actually rejigger and leave the tools of DQMH in place. So if you want to know more about them, check that Dan Press or Mark Balla. I think they're both available probably in the lobby now. Go ahead and put on the, and then there's also a Jörg Hampel from
Hampelsoft.
Hampelsoft, yes, Hampel or Hampelsoft.
Hampelsoft, probably.
Hampelsoft, indeed. And he has gone through the process of figuring out how to do this very specific thing where the idea is, let me see if I can get my mouse over here, is I'm going to break that link between the request and the do. Now, there's no rule in DQMH that says, hey, a specific request has to lead to a very specific action that gets done along the way. And so technically speaking, those event requests are kind of that secondary process that allows a controlled way of getting things into the program. The problem is that from that point in time, there's no brain that's associated with this event structure up top. So things, and I think Jörg and Hampelsoft figured out how to get around that, which is pretty huge. But the big one is that we want to maintain the tools that are available. Obviously, there's Antidoc now can be able to digest it. And there's a lot of other things that we want to leverage those tools. And then also the other one is I still believe in, even though we lose out on a reuse of individual methods that Actor Framework provides and the extensibility of individual dues, that's what Actor Framework gives you, is extensible dues. Extensible doo-doo. I digress. But that idea of maintaining that queued message handler familiarity, because there is that inherent, like I said, familiarity that we have and ease of use that we've got along the way. So keep in mind Prime, consider it. Check out TLB Prime on lavag.org. But in general, here's the big takeaways. if you're doing certain things that you debug based on flow, you're probably wasting your time. It's these common problems, like I said, the happy dance, some of those sniff tests that were along the way. Another big one here is recognizing that your program likely has different modes of operation is the first step towards healing along the way. And explicitly declaring the mode of your program, it makes your program more smarter, good, or better, right, along the way. And I'll go ahead and we were getting these reels. And Darren, go ahead.
All right, forget everything Norm just said. Small modules is kind of my takeaway here. Individually tested, especially with DQMH because it comes for free, makes managing response to things a lot less of a big deal because a lot of that logic that is in the states, the brain of Norm's program, is kind of in the separation of responsibilities with the modules in DQMH. White space is overrated, although Norm probably is rubbing off on me because look at all that white space between the bullets on this slide.
I added
Crap.
Actually, they used to be all.
Oh, so you're playing mind games. Crap. Oh, goodness. All right. So like Norm said, there are some great ideas about how to extend DQMH to maybe make it work more like other people's brains or maybe just Norm's brain. Only do that if you preserve the functionality of the scripting tools. Like Fabiola says, that's the thing that makes DQMH worth using. And in my 7+ years of app development with DQMH, there have been very few times where I've needed to deal with trigger responsive state management. And when I have, it was with a helper loop. So that's also a concept you can take away from this as one of the great ways to extend a DQMH module.
Awesome. So my counterpoint here is this diagram that he thinks has adequate white space because nothing's going to change. There's no what ifs that happen along the way.
I am being mischaracterized here.
It's that small. We got like 5 seconds.
5 seconds.
So, all right. So why settle for force fitting your brain into that mode when really, if your brain speaks and screams state as mine does, then why not let's get that working along the way? And once again, Humplesoft, if you go to his website, he's got a beautiful example using events, registration, and deregistration, and then Prime just along the way.
I had some counter takeaways. Norm made us quit.
So thank you all very much for attending along the way. And once again, I hope as you understood the complaint along the way, you understood the idea of the Prime design, and as a minimum, y'all were entertained.
Thanks, everybody.
Have a great night. Now what do we do?
I don't know.
We'll leave it to him.
Not say anything.
Hey, we made it under 60 minutes.
We did. We better not say anything embarrassing because we might still be live.
That's true. We're probably. Oh wait, there he is.
You are live. Thank you. Thank you for the entertainment and for the awkward silence at the end, or the lack of awkward silence. If y'all want to hang tight, thank you for the entertainment. And we will have another round of 7x7s and another run of our welcome because we are crossing into a new day in UTC, which I guess is the only time zone that matters. So I'm going to hop off for a second here and we will be back shortly.